This is indeed a very tricky and confusing math question. Welcome back to my channel. This is not Drawn to Spell Place, and we are told that from here to here is 4, from here to here is 6, and we are expected to find the area of this square. Please, this is meant to be a square. So we are asked to find the area of this square. Let's name the points A, B, C, D. The point of contact, let's call it M. All right. Now, first things first, let's extend this line AM. Let's extend it to meet at a point. It's very important because that is going to help us a lot. Okay, so I don't know if you can see this point, but I think you should. Now let's call this point P. All right, this point is point P. Now, if you look at this, let's call this A, B, C, D, E, point E, right? You will see that EP should be equal to MP. Yes, because both of them are tangents. Both of them are tangent to this circle, and they meet at a point. Okay, when two tangents coming from a circle meets at a point, their lengths from that point from their meeting point are equal. All right, so it means that EP is equal to MP. Now, this implies that MEP is an isosceles triangle. Isosceles triangle. And remember that for an isosceles triangle, the two base angles are equal. For an isosceles triangle, the two base angles are equal. So this is our theta. That means this place must be equal to theta as well. Now, remember that when you have two lines crossing each other, all right, vertically opposite angles are equal. So if this is theta, this should also be theta, right? If this is 2 theta, this should also be 2 theta. So if you look at point M, you are going to see that the angle here is vertically opposite to this one. So this is also theta. Now, moving forward, you will notice that this angle here, let's call here H. So angle at point H is also theta. I will explain. This is also theta. I will explain. Now, if you look at AH, okay, AH, and you look at HE, and let's draw EP, all right? This is EP, this is HE, and this is A, all right? Now, we are told that this is a square, meaning that AH is what? Parallel to EP. And if that is the case, this simply means that HE is a transversal. Yes, it means that HE is a transversal. Now, if HE is a transversal and we have here as theta, then definitely here should also be theta at H, because these two angles are alternate angles, right? And alternate angles are equal. So that is why this place is theta as well. If this is the first time you are coming across my lovely channel, please click the subscription button and turn on your notification bell. Yes, because if you don't subscribe, this might be the last time you're going to see me. So you need to subscribe so that you will see me all the time. And always comment on our videos. We must reply, and we are there at the comment section. All right, so my shout out today goes to Mustafa Dao 9052. Thank you for always stopping by and for your lovely comments. Now, looking at this now, let's go ahead and establish some facts and find the area of this square. Now, if we say that EP is equal to MP, all right, and that these two angles are equal to these two angles, what does that mean? It simply means that if these two angles are equal, using angle-angle similarity, right? Angle-angle similarity. Using angle-angle similarity. Similarity. Whatever. So using angle-angle similarity, we are going to notice that triangle AHM and triangle PEM or MEP are similar. They are similar. And remember that similar triangles are what? The ratio of the corresponding sides of similar triangles are equal. Ratio of corresponding sides of similar triangles are equal. Now, it simply means that if we say EP over AH is equal to EM over MH or HM, which is equal to 6 over 4, which is equal to 3 over 2. All right? So it means that the side is what? In the ratio of 3:2. Yeah. So if we call EP 3y, it simply means that AH is what? 2y. So let's call this 3y. Then AH is 2y. Now remember that MP is equal to EP. So this side is also 3y, right? Now, I want you to note that triangle AHM is an isosceles triangle. An isosceles triangle. Yes, since the two base angles are equal, it is an isosceles triangle, meaning that the two sides are equal as well. So AM should be equal to AH, which is equal to 2y. So we have 2y here as well. So this side is equal to this side. Now, using this particular theorem that we discussed in the beginning, all right, you can see that AM and A, let's call this point of contact F. I think, do we have F here? No, let's call it F. Okay, AM should be equal to AF. Why? Because both of them are tangents coming from this, meeting at a point A, tangents to this circle, meeting at a point A. So AF should be equal to AM, right? So this place is also 2y. Now, let us form a square. Let us form a square here. Let's join this to the center of this circle. Okay, so it simply means that from here to here is the radius of this circle. From here to here, this is O, is the radius of this circle. This is radius and this is radius. All right, we're almost there. Yes, considering triangle ABP. So let's draw that out. I want to minimize my space. So this is A, this is B, and this is P. A, B, P. All right. So you can see that BP is R plus 3y. AB is 2y plus R. This is 90 degrees. And AP is 2y. AP is 2y plus 3y, which is 5y. Now, using Pythagorean theorem, we are going to have 2y plus r all squared plus r plus 3y all squared will give you 5y squared. So recall that a plus b all squared is a squared plus 2ab plus b squared. So we are going to write this as 2y squared, that is 4y squared, plus 2 times 2y, which is 4y, times r. So it's going to be 4yr plus r squared, plus, then this will give us r squared plus 2 times 3 times 2 times r times 3y will give us 6ry plus 3y squared is 9y squared is equal to 5y squared will give us 25y squared. Okay, I'm trying to minimize my space. So we have 4y squared plus 9y squared, that is 13y squared, plus 4yr plus 6ry or 6yr is 10yr, plus r squared plus r squared is 2r squared is equal to 25y squared. If we transfer this 13y squared to this side, we are going to have 10yr plus 2r squared is equal to 25y squared minus 13y squared, which is 12y squared. Now let's divide through by 2. Divided by 2, divided by 2, divided by 2, and we will have so this will be 10yr, this will be r squared, sorry, this will be 5yr plus r squared is equal to 6y squared. Now let's transfer everything to this side. If we do that, we have 6y squared minus 5yr minus r squared is 0. Now let's replace minus 5y with minus 6yr minus yr, right? So we can actually write this as 6y squared minus 6yr minus yr, then minus r squared is 0. So let's factorize. 6y is common here, we bring it out, then we have y minus r remaining, right? Minus, what is common here is r. We open our brackets. Sorry, this is going to be minus 6yr plus yr rather, because we have minus 5r here, so this is positive. Now when yr is divided by plus r, we are left with y minus r squared divided by r is minus r is 0. So from here we have this in common, right? So factoring that out, we are going to have 6y plus r multiplied by y minus r is equal to 0. So this implies that 6y plus r is equal to 0 and that y minus r is equal to 0. So moving forward from the left, we will see that 6y is equal to negative r. And this is not possible because our r is reduced, it can't be negative. So we are ignoring this and using this, that we will get from here that y is equal to r. Anywhere I see y now, I'm replacing it with r, okay? So this 2y becomes 2r. This 2y here becomes 2r. All right, now let me join center O to this point, perpendicular line. So we have angle 90 degrees. Now let's consider triangle. Let's call their point of contact K. Do we have K here? No. Let's call their point of contact K. So we are going to have another triangle. We have another triangle KHE. And KH is going to give us, remember that from A to H is 2R, all right? And AK is what? R. So it means that KH is 2R minus R, which is R, right? So here is R. This length from here to here is same thing as 2R plus R. So that is 2R plus R, which is 3R. Good. Now from here to here, which is HE, is 10. And this is 90 degrees. So using the Pythagorean theorem, you will see that 3R squared plus R squared is equal to 10 squared. So we have 9R squared plus R squared is equal to 100. 10R squared is equal to 100. Divide by 10, divide by 10. And you have that R squared is equal to 10. So we are keeping that the R squared is equal to 10. So remember that we are asked to find the area of this square. And as a result of that, because this is a square, area of a square is length squared. And one length of this is 2R plus R, right? Which is 3R. So it's going to be 3R squared, which is 9R squared, which is 9. Pardon me, it's raining, but I need to finish this video. Yes. So R squared is already 10. So it means that the area of this square is 90 units squared. Thank you so much for watching and see you in the next video. Bye.